In this demonstration, I'm going to show you how to find probability from a normal distribution. Since we know there's a correspondence between area and probability, we can use the area under a density curve to calculate probability for populations that are normally distributed. As I'm going to show you, it's much simpler to understand these distributions if you sketch a curve and shade the area for which you need to find the probability. In each of the three examples that I'm going to show you, I'm going to be using a standard normal distribution table that shows the cumulative area from the left, and I'll show you how to read that table to calculate probability. The first example I'm going to do is the probability for area of z less than negative 2.04. In our examples, we're going to assume that values are normally distributed with a mean of 0 and a standard deviation of 1. So let's find the probability of a score less than negative 2.04. The most important step in any problem such as this is to sketch your curve. So if you don't have a curve on which to draw, you can just sketch a curve. It doesn't have to be perfect. You can just sketch a line with a curve over top, because this is just a sketch for you to visualize what area you are searching for. Label the given information. In every single normal curve, your mean is going to be in the middle. In this case, our values are normally distributed with a mean of 0 and a standard deviation of 1. Shade the region of interest. Our z-score of negative 2.04 is going to be to the left of the mean, because all negative z-scores are to the left of the mean. So anywhere over here on the left, it doesn't have to be exact, just somewhere on the left, draw a line for negative 2.04. And again, this is a sketch. It doesn't need to be exact. We want to know less than 2.04. So the area that's less than 2.04 is going to be this area right here. So now I have an image of the area that I'm trying to find. So I need to get a normal distribution table on which I can look up the area. Let's take a look at this negative side of the z-score table. Look at the image that's at the top of this table and notice that it matches our image. That's telling us that this z-score table, the values in the middle of the table, are giving us the area in this blue part that's shaded. So any z that we find up to the value of 0 is going to be that cumulative area up to that z. So we're interested in 2.04. Negative 2.04 up to that point. So we come over on the left and we find negative 2.04. So we find negative 2 and we come over to 0.04. And we find that the area in that shaded region is 0.0207. So this tells me that my area for this part of my curve is 0.0207. So the probability of a score less than negative 2.04 is 2.07%. Let's try another example. Again, assume the values are normally distributed with a mean of 0 and a standard deviation of 1. Let's find the probability of a score greater than negative 1.50. As always, the most important step is to sketch your curve. And this is a problem where you're going to see why this is extremely important. Again, the mean is in the middle. My z is to the left of the mean, once again, because it's a negative value. So sketch it anywhere to the left and label it negative 1.50. But this time, I want to know the probability of being greater than my z-score. So I'm interested in all the values to the right. So again, I need to look at my area on the normal distribution table. So let's get our normal distribution table up again. So here we have our negative distribution table. Recall that in this table, the areas are being given in the tail. But in this problem, we need the area over here. That's not a problem. Let's look up the area in the tail. We need negative 1.50. So let's come down here to negative 1.5 and come over to 0.0. So it's 0.0068. So the area right here is 0.0668. Well, I know the entire distribution is 100%, or 1, since I'm working in decimal form. So if I know if up to this point is 0.0668, and I know that the whole thing equals 1, then I can find the unknown portion by subtracting what I know from 1. So I say 1 minus 0.0668 to get the unknown portion. So my unknown portion is 0.9332. So this value over here is 0.9332. So my probability of being greater than negative 1.50 is 93.32%, which really makes sense. If you look at the shaded portion of that bell curve, it's approximately 93% of that bell curve is shaded in. A large portion of the bell curve is shaded in. It makes sense. Let's do another example. In this example, we're going to find the probability of lying between two z-scores, between a negative z-score and a positive z-score. What's the probability of being between negative 2.2 and 2.50? Again, let's sketch the curve. So our first z-score is going to lie over here on the left at negative 2.20, and our other z-score is going to lie over here on the right at a positive 2.5. And I want to know the probability of falling in between. So I'm going to need my z-score chart to look up these values. In this problem, I need to work from my negative chart as well as my positive chart. So first let's look up our negative z-value of negative 2.20. So looking more closely at this chart, I see that negative 2.20 is an area of 0.0139. But that amount is right here in the tail, 0.0139. And in our positive 2.50, let's see what that is. That's at 0.9938. That value, notice, goes from this tail all the way up to here. So it starts here and it goes all the way up to here. So that amount is 0.9938. So we have counted this portion twice. We've overlapped. So what we need to do to find this area in red that we're interested in is subtract the two areas to get rid of this part that's been counted twice. So we need to say 0.9938 minus 0.0139 to get the area that we're interested in, which is 0.9799. So the probability of being between negative 2.20 and 2.50 is 97.99%.